if you did a little experiment like this and you want to look at the strength of an electromagnet, then you could change various things to try and make your electromagnet stronger. And this just shows the results of an experiment that was carried out. And the experiment shows here that the number of batteries in the circuit was changed, more current flowing in the circuit, and that the electromagnet picked up more paper clips. You can see the number of paper clips it's picking up is going up and up. More turns of coil in the wire, again, you've got more paper clips. So that's two ways. The third way is to make sure that you have a piece of iron in the centre or a magnetic material. So the first way is more current, more coils, and use an iron core. What happens if you were to turn the battery around? So if you had your battery plus minus here and you changed it around, well, what you would do is you would be changing your poles around, because your current would be flowing the opposite direction through your coil, and your right hand grip rule then would be used the other way around. Obviously in this case, if this is the north pole, then it's actually pointing down that way there. Okay, so again, we'll just have a wee look at this, a wee practice. If you want to draw it yourself, you can stop the video cast and draw it on yourself. Draw a wee diagram and draw it yourself. Okay, so when you close the switch, you've got your positive of your battery here, so that means the current is flowing this direction. I'll put that on in blue. So it's going up over the top there. So that's the first thing you do. The next thing then that you do is put your right hand down and determine the direction of the north pole. So current's going up over the top, your fingers are going up over the top, curling in the back, and there's your north pole there. Next thing that you do is draw the shape of your line. So one line in the middle, at least one loop in the top, and at least one complete loop in the bottom, which goes right inside the coils. Last thing that you do, V lines go from north into south, north into south, like that. And that's the shape of your field around a solenoid. Okay, I've just got a couple of questions here. John is investigating the lifting power of an electromagnet. He finds the electromagnet is just not strong enough to lift the iron ball when the switch is closed. State two ways in which you could make the electromagnet stronger. So, you know at least two ways. He probably isn't going to change his core here, but he could. You have a larger core, but the most obvious two ways are to increase the amount of current or increase the amount of coils. So increase current or increase coils. Now this is another electromagnetic circuit, and you can see in this bottom circuit here that you've got a variable resistor, a switch, and then an electromagnet. And so it asks you to say what happens whenever you switch on the electromagnet. So whenever you switch on the electromagnet, you can see the current is going this way and down over the front here. And if you had to decide which was north, which was south, and you're asked to put in north and south here, then your fingers have to go in around the back of that like this. And this end here is the north. I'm using my right hand, so this end is the north. So there's your north pole and your south pole. So once that becomes a magnet, provided your load is made from something like iron, then it's going to attract your load down. What do you think will happen whenever you increase the size of the current or use a variable resistor to increase the size of the current? Your electromagnet then will get stronger and your load should move down more, so your pointer should move down more. So this is a way of using an electromagnet to determine a scale here, determine what the attraction is between the load and the electromagnet. This is another question. It tells you that a strong magnet is lowered down towards an iron plate, which is sitting on a top pan balance as shown below. Now, the iron plate we are presuming here, as it's only called an iron plate, it's not a magnet, so it isn't previously magnetised. So what is iron going to do when it sees a magnet? It's going to be attracted upwards towards it. So what would you expect your scale to do? You would of course expect your scale to decrease And the reason is because your iron plate is being attracted towards the magnet. There's a non-contact force there which is attracting it upwards, and therefore it's going to read not as heavy. Now there's a few applications you have to know. And one of the applications you have to know is the electric bell. And this is a normal circuit that you would meet which has an electric bell in it. So you have got a power supply switch which is open. This represents you pushing the bell, so you would be putting your finger on it. Complete circuit here through the electromagnet, and this core part here would be made of iron, and you've got a wire wrapped around it. And then you've got a springy metal strip which is part A here, and it's connected then down to the hammer which will hit the gong whenever the bell rings. There's another wee bit here as well, which is just making contact with this screw. So once you complete the or close the switch, then you have several things which happen, and it's really best if you can list those in order of how they happen, and that will really set you up to getting 5 marks. This is generally a 5-mark question. Explain how it works, or explain what happens whenever when the switch is pressed. So whenever you press the switch, current flows around the magnet. So the first thing then is that the circuit is complete. And you could also maybe write that current flows. Right, then what happens next is that the electromagnet is switched on or magnetised. I'm going to write EMAG is on. It will then attract this soft iron armature. So it would be labelled, or you might be expected to label this part A, it would be made of soft iron. So the armature is attracted to the electromagnet. As it is attracted to the electromagnet, the hammer hits the bell. But there's something happens over here then. You can see that this spring moves away from the contact. So the contact is broken at the screw part, which is here. This is a little screw. And what happens when the contact is broken? You've now a gap in the circuit, and the circuit is switched off. So the E-magnet is off, and the iron armature moves back. Oh, I see you can't see that bit, so now when all that happens, it moves back, that completes the circuit again. The electromagnet attracts the armature, hammer hits a gong, circuit is broken, moves back again, and so on and so on. For as long as you have your finger in the switch, that happens forward and back, forward and back. And what you really hear there just is the bell ringing.